we are going to solve this graphically. So we're going to practice using our graphing calculator to solve this equation. So the first thing I want you to do is to enter this equation into your graphing calculator. X squared minus x minus 3. That's what we're going to type in there. Push zoom and 6 to get back to a standard window. And your graph should look like this. According to your graph, can you see that there are two x-intercepts?
Yes.
So with your two x-intercepts, you know that there should be two solutions. We already knew that as well from the fact that our discriminant is a positive number. If our discriminant's a positive number, we would know that there are two roots to this equation. Now we're going to find those roots to one decimal place. Two options are to use your quadratic formula, because that would find it. But what we're going to do is we're going to use our graphing calculator to find those two roots. Again, we push second, trace. That gets us to the calculate menu. And we're going to want to calculate number 2, the zeros. Second and then trace button. So we hit the second button and then the trace button, which gets us to the calculate menu. And then the second one on our calculate menu says zeros. Push enter on that one. So you should have your graph up there. It's going to ask you to go to the left and to the right of one of the ones you want to find. So you can use your arrow keys to go left. And let's say right now my cursor is really close to that x-intercept. So I want to find that one first. I'm going to keep using my arrow keys until my cursor is to the left. Doesn't matter how far to the left you go, and push enter. Now on my calculator, it does an arrow with a little line. Your calculator probably just has the little arrow. 1 second, Andrew, I'll finish explaining it first. Once you've got to the left side of it, then you'll need to go to the right side of it. So now I move my cursor till it's past it. My cursor is now to the right of it. Again, with the new calculator, the dotted lines really show that my x-intercept is in between the two that I chose. If you have a newest calculator, it'll have that. The color one, I think, does. The older ones just have the little arrows at the top. So if yours just you have to push enter when you go left and right. Then once you've got both those arrows, it's going to ask you to guess. You push enter one more time, and it finds it exactly for you. Negative 1.3. That is one of our answers. Looking at our graph, could you estimate where the one on the right is? After 2 but before 3? So do you say maybe 2.3 you would estimate it at? I'm going to show you a shortcut now for how to do the left and the right. If you are good at estimating it, we're going to calculate second trace, go to number 2, the 0, and we're going to calculate the second one. Well, you said that 2 was to the left of it. So instead of using my arrow keys to get there, I'm just going to type in 2 and push enter, and it'll automatically take my cursor to 2, which is a little bit faster. And to the right of it would be 3. So I'll do that. And then push enter. And we find out that our other one is at positive 2.3. So that's how you can use your graphing calculator to find those zeros. If we go to our discriminant now and do our b squared For C, we predicted 2 because we got 13 for the discriminant. And in D here, if I check out what b squared to be 1 squared minus 4, a is 1, c is 3, I get negative 11. If the discriminant is negative, how many x-intercepts or how many zeros will it have?
-0.
It'll have none. So now when we graph this one, and a couple of nice things that happen with the graph, you go to y equals. The only thing different is these are plus signs, so I can just go over top of my plus signs, plus, plus, and I graph it now. And we notice our graph, no x-intercepts. So anytime that your discriminant is negative, you're going to have a graph that never touches your x-axis. So I want you to solve some graphically. So if you go to the Assess Your Understanding, practice getting the roots with questions 2 and 3. Use graphing technology to solve each equation. Question 2 and 3.